Alright class, so I hope you're doing well with the substitute so far. So today you're going to be watching this video and answering the questions that are on your worksheet that have been given to you. All the questions are going to go straight with the video, so you won't have to fill in any answers you're not sure of. If you're not sure, just fill in what we have in our video. So today we're learning about the mean again, and today we're going to learn about the mean as a balance point. Our I can statement is I can characterize the center of a distribution by its mean in the sense of a balance point. So what does this balance mean? Well, think of it when you have like a seesaw. For it to be balanced, there needs to be equal weight on this side and equal weight on this side, and then what will happen is it's going to form that straight line that we talked about in class yesterday. When something is balanced, then it's going to be a straight line. This refers to that fair share that we talked about yesterday. So we're looking at fair share or mean again as a balance point. Our I can statement is I can understand that the mean is a balance point by calculating the distances of the data points from the mean and call the distances deviations. This word I'll tell you is on your test tomorrow. So what does deviations mean? Well, it's the data points from the mean and their distances, and we are going to be doing some calculations to learn about the distance and its relationship to the mean, and that is our deviation. Okay, so example 1. Sabina wants to know how long it takes students to get to school. She asks 2 students how long it takes them to get to school. It takes one student 1 minute and another student 11 minutes. Sabina wants these data on a ruler, putting a penny at 1 and another at 11, and shows that the ruler balances on the eraser at a point of 6. So if I were to take a ruler and I put a penny on one end, a penny on the other, I'd have to put my finger or an eraser at 6 for it to balance so that it wouldn't tip one side or the other. Note that the mean of 1 and 11 is also 6. So how do we find that mean again? Well, I add my numbers up, so I have a 1 and I have an 11. So I add my numbers and I get 12, and then I divide by the amount of numbers I added. So how many numbers did I add? Well, I added 1, 2, so that means I'm going to divide by 2, and that will give me 6, which also matches this example with a penny and a ruler. Sabina thinks that there might be a connection between the mean of 2 data points and where they balance on a ruler. She thinks that the mean may be a balancing point. What do you think? Will Sabina's ruler balance at 6? Is the mean of 1 and 11 equal to 6? Sabina shows her result on a dot plot. So what do you think? Will Sabina's ruler balance at 6? Yes, it is going to balance at 6. If you're not sure or you don't believe it, then at the end of this lesson you can get a ruler and try this yourself. But it will balance only if I put that eraser at 6. So is 6 the mean of 1 and 11? Yeah, it is. We just proved that right up here. So 6 is also the mean. Where it balances is also the mean. Alright, Sabina decides to move the penny at 1 to 4. So she's moving it from 1 to 4. And the other penny from 11 to 8. Noting that the movements for the 2 pennies is the same distance, but in opposite directions. So notice how far we moved it. We moved it 1, 2, 3. We move this one 1, 2, 3. So it's the same distance, but in opposite directions. She notices that the ruler is still going to balance at that 6. Sabina decides that if data points move the same distance, but in opposite directions, the balancing point on the ruler does not change. Does that make sense? So what it's asking is this. If I move the penny one spot over here and one spot over here, will the middle still be 6? Yeah, the middle is still going to be 6. What if I move my 4 to 5 and my 8 I move at 1? Is the middle of 5 and 7 still 6? Yeah, it's still 6. So as long as we're moving them in the same direction, or in the opposite direction, but the same amount, it's not going to change our middle or that mean. Notice that this implies that the mean of the time to get to school for two students who take 4 minutes and 8 minutes is also 6 minutes. So the mean time for 1 and 11 is 6. For this one we just showed, if a student takes 4 minutes and 8 minutes, their average time will still be 6 as well. So that balancing point, it's still going to be our mean of 6. The balancing point is still going to be 6. If you're not sure, at the end of this lesson, you can test it out with that ruler as well for balancing. And you'll notice the ruler will stay in a perfect, flat, straight line. Okay, Sabina continues by moving the penny at 4 to 6. To keep the ruler balanced at 6, how far should Sabina move the penny at 8 and in what direction? So let's look back here. We're moving it from 4 to where? I'm moving it from 4 to 6. So it's asking me, how far should I move the penny? Well, we just learned if I move it 2 jumps this way, to keep it balanced, I have to do that same number of jumps, but in the opposite direction. So I need to move it 2 jumps, but in the opposite direction. So let's answer this one first. How far is she moving the pennies? Well, she's moving it 2 inches or 2 jumps since it's on a ruler. How far should she also move it? She should move the other penny 2 inches also because it has that 2 jumps. So the last thing is, if she is moving the penny from 8, where should it be placed? Well, let's look. We did 1, 2 jumps, and I end up on 6. So we should move it to 6. Don't forget to be filling out your notes as we go along. Okay, now it's your turn to try balancing 2 pennies on a ruler. Some of these you won't be doing just because you have a substitute. So if I cross out, you don't need to do them. Take 1 penny at 2.5 on your ruler. Okay, guess what? We won't be doing this one, and we won't be doing these ones. And we won't be doing 2A, B, or C. We may do those on our way back when I return on Monday, or we may not. Okay, we're going to watch a video on how we find the mean, explained by other 6th grade students.
I'll show you how to find the mean of a set of numbers. Before I start my demonstration, I must tell you that the mean means the exact same thing as finding the average. So if you already know how to find the average, then that means you already know how to find the mean. Here is a set of numbers for our demonstration. Step 1 is really easy. All you have to do is find the sum of the numbers, which means to add all the numbers up. So we write 4.10 plus 3.75 plus 8.15 plus 9, and lastly plus 5. And that gives us a total of 30. We have now completed step 1, and step 2 is even easier. Step 2 is to divide the sum, which we know is 30, by how many numbers there are. So we divide 30 by 1, 2, 3, 4, and 5. Because there are 5 numbers, we divide 30 by 5. 30 divided by 5 gives us a total of 6. To check our answer, we can look at the set of numbers and guess if 6 seems to be a reasonable answer. 4.10, 3.75, 8.15, 9, and 5 all seem to be pretty close to 6. And 6 does seem like to be the middle of all the numbers. So we now know that 6 is the mean of all those numbers. I hope you found my video helpful, and I hope you know how to find the mean now. And thanks for watching.
Alright, so let's continue. We're going to walk through part of your worksheet now. So we're going to look at this, and we're going to learn about that keyword deviations now. Alright, so let's look at Sabina's initial placement of pennies at 1 and at 11 with a mean of 6. Notice how the deviations are 5 and negative 5. Well, how am I getting these deviations? Well, what I'm doing is I'm looking at my mean, my middle part, and I'm saying, how do I get from 1 to 6? How do I get from 11 to 5? Well, what I do is I take my value, so my value is 1, and I'm going to subtract my mean. So my mean is 6. 1 minus 6, that's a negative 5. I'm going to take my value, which is 11, and I'm going to subtract my mean, which is 6. So this deviation is 5. My 1 is a negative 5. So this is what deviations mean. So I suggest you write this down because it will be on your test. Deviations, and I'm going to abbreviate it. Deviations are your value minus the mean. What this tells us is how far our value is away from the mean. I see that this 11 value is 5 inches away from my mean. Alright, so let's look at this next part. Similarly, so that means very close to, or like, when Sabina moved the pennies from 4 to 8. So we have a penny at 4, we have a penny at 8. What would their deviations be? Well, it's my value. I have a value of 4 minus 6. So this deviation is negative 2. Over here, my deviation is 8. That's my value minus my mean. My mean is still 6. So this 8 has a deviation of 2. I want you to notice something. What do you notice about my deviations? Well, I should notice that when I add my deviations, I get 0. It was the same thing when I had my deviations of negative 5 and 5. When I add my deviations, I get 0. Whenever I add my deviations together, I get that 0. That 0 lets me know that it's at a balancing point and that I did my math correctly. Alright, so let's keep going. You guys are going to skip exercise 3. You're going to skip exercise 4. Okay, so now we are on example number 3. Now we're going to balance more than 2 points. Before, we just had a penny on one side and a penny on the other. But what happens if we have 3 pennies? So Sabina wants to know what happens if there are more than 2 data points. Suppose that there are 3 students at school. One lives 2 minutes away, another one lives 9 minutes away from school. The mean time for all 3 of these students is 6. She wonders how long it takes to get the 3rd student to school. She puts pennies at 2 and 9, and by experimenting, so we haven't figured out mathematically, just by experimenting, she figured out that she needs to place it at 7. And then it's going to balance. To check what she found, she calculates deviations. So I'm going to check my deviations. My mean is 6. My first data point is 2. So I have 2 minus 6 equals, and just so we can keep track, I'm going to do all my deviations in blue. Here I have 9. So remember, deviations is your value minus your mean. So I have 9 minus, my mean is 6, equals -3. And this one, I have a value of 7 minus 6 equals -1. So what should happen when I add all my values again? All my deviations, when I add them, should equal what? Should equal that 0. So let's check. 4 minus 1 minus 3, that equals -7. It should equal 0. So that means I did something wrong. I need to check my work. What did I do wrong? Well, hopefully you notice 7 minus 6 is not a -1, that's a +1. 9 minus 6 is a +3. So I should have -4 plus 1 plus 3. Now when I do my math, what do I see? I see that it equals 0, just like it should. Now what does this 7 mean again? This 7 means that it takes her 7 minutes to get to school. What does my deviation tell me though? My deviation is 1, so that tells me that it takes her 1 minute longer than the average time. This 9 has a deviation of 3, so this student takes 3 minutes longer than my average student. Okay, let's keep going. All right, you guys are going to do number 5. You can do it by yourself, or you can do it with me. So suppose we place a penny at 3, 7, and 8. So I have a penny at 3, 7, and 8. Sketch a picture of the ruler. What value do you think you will get? At what value do you think that ruler will balance? Do you think it's going to be 6 again or something else? Well, it is your guess, so take your best educated guess. But now we're going to do some mathematics just to check. We have 2 ways. I'm going to pick our easy way of finding our mean, because that mean is what? That is your balance point. So I'm going to find the mean of 3, 7, and 8. So let's check. I add all these up. This is 10. 10 plus 8 is 18. I have 1, 2, 3 numbers. So I divide by 3, and that gives me 6. So where should it be? Well, this is telling me my balance point is at 6. However, I'm not sure because this is a new concept, so I'm just going to check. I'm going to find all my deviations, add them together, and they should equal 0. So I'm going to do my deviations in blue again. It's my value minus the mean. So my value is 3 minus my mean is 6. So that will equal something, which is a -3. Value minus mean equals 1. Value minus mean equals 2. When I add all these up, I have -3 plus 1 plus 2. That equals 0. So it does look like this is my mean. Okay? So now let's go to C. This is telling me show part A on a dot plot. So what does that mean? All I'm doing is I am taking 3, 7, and 8, putting them on a dot plot, and it says mark the balancing point, or that mean, with a triangle. Now, what are the deviations for each of the data points? What is the sum of the deviations? What is the value of the mean? Well, my value of the mean is 6, and we already solved that deviation question up here. So if you want, you can draw an arrow to where your work was, or you can redo your deviations down here. Okay, now let's go on to number 6. Now suppose you place a penny at 7 and 9 on your ruler. Draw a dot plot, so 7 and 9. Estimate where to place a third penny on your ruler so that it balances at 6. So this one you're going to have to think. If I put a penny here, is it going to balance? No, it's going to tip this way. So I have to put it on the opposite side. What if I put it here? Will it balance? What about here? Will it balance? Well, remember, I need to find a balance point where my deviations, when I add them up, will equal 0. So let's see what my deviations are over here. Remember, deviations is your value minus the mean. So this one is 7 minus 6 is 1. 9 minus 6 is 3. So if I add these ones up, I get 4. So that means on this side, I'm going to have to get a negative 4 so that it balances. Because 4 minus 4 equals 0. That's what it needs to be. So I'm going to do 1, 2, 3, 4. And just to check my math, I'm going to do 2 minus 6 equals, and that does equal that negative 4. And then when I add them together, it'll be that 0. So there is my estimation. We're just going to clean this up a bit. Estimate where you would place that third penny. We would place it at 2. And mark the point on the dot plot above. Mark that balancing point, like we did. Explain why your answer in part B is true by calculating the deviations from 6. Is the sum of the deviations equal 0? Yes, it was. And then you can say your deviation work and draw an arrow to wherever you did your deviation work. If you didn't do it, you can redo it down here. And I'm just going to explain why it works. So we need a sentence 2, just because it's asking us to explain. The deviations, when added together, should equal 0. So that's my explanation, and my work was above it. Alright, let's keep going. Okay, number 7. Suppose you place 2 pennies at 7 and 9 on your ruler. Draw a dot plot to show these 3 pennies, it says, but I don't have 3, so that was my typo. So I need one at 7 and one at 9. And, oops, I'm sorry. I remember what I wanted. That one at 2. Now, part B is asking us to place a 4th penny so that it still balances at 6. So what can we do? Well, from my previous problem, I already know that this has a deviation of negative 4, 1, and 3. When I add all of these up, it equals what? It equals 0. So I already know it's balanced, but yet it wants me to add another penny. So where can I add it so that I don't change its deviation? Well, let's start by looking at some issues. If I put it here, this would have a deviation of negative 2, which then, when I add it, wouldn't be 0 anymore. What if I add it here? Well, that's negative 1, so that means it will tip and fall over this way. Oops, and I erased part of that triangle. What if I add it here? Well, then it actually has a deviation of 0. Can I add 0 to this and it will still be 0? Yeah. So what I need to do is I need to add that penny right on top of the balancing point. It makes sense too. If this ruler is balanced, I can put stuff directly on top of it and it's not going to make it unbalanced. Okay, so now I need to show how this is true by calculating those deviations. Well, I can say my deviations were -4, 1, and 3. Oops, but I need to spell that "and" correctly. From problem 6. My new deviation, I'm going to abbreviate deviation, is 6. Remember, deviations are your value minus the mean. So my value is 6 minus 6 equals 0. And then I'm just going to type this last part. And I'm going to type it over here, just because I'm running a little bit out of room. When, oops. So when I add -4, 1, 3, and 0 together, I get 0. So I'm just going to put a concluding statement. So the deviations, I need to spell deviations right, still add up to 0. So that is my sentence that goes with my explanation. All right, let's keep going. Not all distributions on a ruler are going to have a fair share mean, or a balance of 6. What if the data were 1, 3, and 8? Would your ruler still balance at 6? Why or why not? So if I put a penny here, here, and here, it would still be 6. All of our examples we've done so far have been 6. But let's check this one. So here I have a deviation of -5, deviation of -3, and a deviation of 2. So when I add all these up, what do I get? Well, -5 minus 3 plus 2, this is a -8 plus 2 equals a -6 for my sum of deviations. Remember, this should equal 0 for it to be a balancing point. So right there it's telling me I did something wrong. So guess my balance point won't always be 6. So how can I find my balance point? Well, I'm going to find my mean of those numbers and then check to see if that's its balance point. So I have 1, 3, and 8. Remember, your mean is you add all your numbers up. This will be 1 plus 3 is 4, plus 8 is 12. And then I divide by how many numbers I added. I added 1, 2, 3 numbers. So I divide by 3. 12 divided by 3 is 4. So this is telling me, I think my balancing point should be at 4. Let's check. 1, so I'm finding those deviations again. 1 minus 4 is -3. Then I'm going to go find the deviation of my 3. So 3 minus 4, that's my mean, is -1. And then I have 8 minus my mean is 4. So here are my deviations. When I add my deviations up, what should I get? It should be 0. So let's check. -1 minus 3, that's a -4. And then I need to add this 4 on. And -4 plus 4 is that 0. So where is my mean? My mean is 4. What is my balancing point? It is also 4. All right, let's keep going. Okay, exercise 8. Use what you have learned about the mean to answer the following questions. Recall in Lesson 6 that Michelle asked 10 of her questions for the number of hours they usually sleep when they're at school the next day. Their responses were 8, 10, 8, 8, 11, 11, 9, 8, 10, 7. So it's going to be hard to actually put 10 pennies on a ruler. So now we're going to switch to dot plots because we're using larger data sets. So I have 8, 10, 8, 8, and there's my 10. I have 2 11s, so 1, 2. I have 1, 9, 1, 8, 1, 10, and 1, 7. So use your dot plot to find the balancing point. What is the sum of the deviations for the data points from the fair share mean of 9 hours? Well, let's look at some key facts in here to help us. It says we need to find the data or the balance point, so that means we need to put that little triangle in. But let's look at this because it's actually giving us some hints. What is the sum of the deviations from the fair share mean? Well, this is already telling us what's our mean. Our mean is 9. It's telling me right here, we found it in our problem yesterday. Our fair share mean is 9. A balance point mean, that's the same thing. They're both means or averages. So I know my balance point is 9. So now let's check. It's saying, what is the sum of the deviations? Well, what should my deviations always add up to? Remember, sum means add. They should always add up to what? 0. Every single time it should add up to 0. So I don't even need to do any math because I know my deviations will always add up to 0 if I have that correct mean. Okay, so now what you're going to do is you're going to do your exit ticket. So you have it on the back of your lesson. So I'm going to have you finish that. When your exit ticket is done, you can go on Dreambox for the rest of the day. At the end of the day, be sure you plug your computers in. Those black cords are plugged in. And I hope I get a good report from you when I come back to school this afternoon to get ready for tomorrow's sub. All right, good job, guys.